In this video, we're going to be taking a look at the primary use for Excel that you'll be using, which is data manipulation, largely in the form of tables. Sometimes you'll use it for other aspects of data management, but largely tables is the thing. So let's go ahead and jump in here. One of the first things you can do is you create a table on your spreadsheet. You just type in the field. Remember that there are numbers and there are text, which we call strings. And so let's type in here data 1 and into the neighboring one data 2. Let's capitalize that, data 2. Enter. So that is a string of text. Data 1 and data 2, even though there's numbers in there, even though there's numbers inside the text, it's counted as only a string. So now in the column 1 or data 1, let's type in there 1, 4, 8, 9, 6, 5, 2. All right, and then under data 2, we'll just put some random values. Of course, in a real situation, you'd be using actual data that you took from experiment. So let's put 1.1, 1.5, 6.9. Oh, I put 6.9, 2.4, and 8.15. Oops. So 5.0 and 2.8. Okay, so this is just our data here. Now you can do formatting if you'd like, and that's all well and good, but for the most part, we have entered data in here. Now, it doesn't have to only be data. It can be strings of information. For example, if we said that one was in people and cars and so forth, but we're not going to do that. That's not what we're going to do in here, but it's possible. However, this data is now presentable for any type of purpose that you want to use. What you may notice, though, is that the formatting doesn't look all that great. So let's do some formatting here and just see what we can do about that. So I'm going to highlight the data. You can either click on one and then use your the shift and the arrow keys to copy all that, or you can move your mouse and capture all that data. Once you've got it captured, you can come up to the top, hit center, and then you see that all the data is centered. That's nice. We can make it bold if we want to, make it a little stand out, a little bit more punch in the paper that you present, or whatever other format you're going to do. You can make the size a little bit larger. You can put here in this little grid, go in there. And there are some other tricks that can be done, but by and large, we're not going. Those are more used in advanced situations. Now, when you look at this data, you say, oh wait, we've got this 5 here that is not enough decimal places. Well, you may recall that we just highlight that and hit one of these, and you see this is adding an extra 0 to everything. But now we take that 0 back away, and the 5.0 is presented as a number with a specific number of decimal places, and your number of sig figs is preserved. So that's a little bit of formatting there. You can also color this if you want to, but the most important part is that you can now highlight this, copy, and paste it into a Word document, whether it's Microsoft Word, Google Sheets, or what have you. Something that's nice about these programs is that you can resort the data if you decide that the way that it was originally presented is not in the right order. So you notice that I've got numbers that there's just no pattern here. I picked numbers at random. So let's highlight this data here. And if we go up to data here, up the ribbon, the data tab, you'll find that there's a lot of stuff that we can do, and you can explore this on your own time, but for our purposes, let's go to sort. When you click on sort, it brings up a text box that you can choose. When you click on the drop menu, you'll see that you can choose one of your data 1 or data 2 columns. It's already preset. Now you'll notice it says my data has headers over here in the upper right corner of the floating box, but we're going to organize this by data 1. Let's say that maybe there's a way to extract a trend when the data has been given to you out of order. You can extract a trend when you take a look at it. So then we click OK, and you see now it has reorganized data 1, 2, 4, 5, 6, 8, 9 numerical order, ascending, and you can also change it to descending so that it's going down as well. But you notice what it did was it also moved the data 2 that's associated with data 1 when it moved data 1. So it shifts everything in the order that you want to. Of course, we can do the same and highlight this and change it to sort according to data 2. And there you have it. Very useful tool when doing some data analysis. Sometimes it just helps to look at your data organized according to one particular measurable as opposed to another. But what if your data comes to you in a large file? Let's take a look at importing data. Most of the data that you're going to deal with is going to be exported from your laboratory experimental software in either a CSV file format or an XLSX format, depending on what your settings are in that system. Most of them nowadays are able to export directly into XLSX. So we're going to treat it as though it is in that case. So what we'll do is let's go to File. We will open a file that we're looking for. I'm going to browse to it. I don't use all these extra shortcuts that Microsoft has invented. And I'm going to click on the file that I'm looking for. You navigate to where your file is, and here I've got this raw data. So I'm going to double click on this. And here your data shows up, ready to roll. Now, remember that first thing you can do is come in here. Sometimes the data is also squinched up, so you can just highlight the entire system and double click on the space in between, just like we did in a previous video, and it resizes all the columns to what your data is, the maximum size content for that particular column. You'll notice that this data says run 1, run 2, run 3. As it turns out, the most recent data that you get is going to be the best quality one. So we're going to go ahead and work with run 3. Now, it's best to work with your data in its own space. You don't want to corrupt your raw data file in case there's something went wrong. You can go back and get that raw data and start over again. At least it won't be having to track down the original data from somebody else, or maybe come back into the lab and have to rerun the data altogether. So we're going to go down to the bottom and we're going to click on the plus here to create a new worksheet, and then we'll double click on that. Let's label this data number 3 and we'll hit that to empty it, to enter it. Go back over to Pascal Motion Sensor Data Raw. The first time, this is the raw data. We're going to highlight these columns. Remember, this captures everything in that column. You can go and specifically capture this, but oftentimes you're going to have data that's going to be really long, and this can be very time consuming and inefficient. So we're just going to highlight the entire columns across the top row. Control copy to copy it, or you can right click and go down to copy. That's fine too. Come into data. I can control V here since I controlled C there. I'm going to go ahead and right click and use the menu here just again to show you your options. Now you have some different paste options here, and you want to take a look at what they are. One is paste P, which pastes it directly in there. Paste V, which is just values, and you see what that does to date and time when I do that, so maybe we want to avoid that. Formulas, which it pastes in only formula forms whenever those exist, and then transpose just flips your columns and your rows and columns. So there are uses for that, but we're not going to deal with that. And then a few other paste options. So it's just a matter of, in this case, just go ahead and hit paste regular, and that pastes it into place. You can also, again, control V to get this data here. Good, so now the data is here. Now, let's take a quick look at the data here. You have column 1, which is date and time, and you notice that it's got a date and a time stamp. That's the actual system time that was stamped into that data point when it was collected. And then you have a second column here, which says time. Well, the second column starts from time 0 with that date and time stamp, and then all the other ones are measured as relative to that one date and time stamp. So the first column, column A, is actually full of information that we just really don't need. It's extraneous even. What we're mostly interested in is the time, position, velocity, and acceleration. So that'll be these two. You can delete this data. You can dismiss it. You can remove it. You can leave it there if you like. This is a copy of our raw data, so we can do whatever we want with this data scientifically, and it'll be fine. So let's go ahead and delete it just for the moment, and come on over here and look at these other 4 columns. Now, time and position, the difference here is time and position are going to be your data that you actually took measurements of. These are physical measurements that the system performed. Now, velocity and acceleration are derived quantities. We derive them from the position and the time values. The position was measured specifically by the motion sensor, and time is measured by the internal timer of the system. Velocity and acceleration are derived from those, and so they were not directly measured. And so you'll notice that for the first couple data points, that data is unreliable, or at least is missing some. So we could neglect that data if we needed to, and for some of our analysis we will in fact and neglect it. So when you go to put this into a Word document to present, depending on the data that you're presenting, sometimes you need to present the whole data, and sometimes you just need to present some representative data. In this case, because this is all a lot of data points from a single process of data collection, you can just grab little chunks. So let's copy, Control C, Control V, and then you can just take a few chunks of those and paste them into place here. Maybe scroll down and get something a little bit later. And what's important is not that you are cherry picking. You're not cherry picking data. All you're doing is grabbing random samples. And when you paste this into your Word document, that's important part to put into your caption for this data table. This is some random sample of the data that was used to do your analysis. So this is fine right now to make a point that we're trying to make. So let's go ahead and clean this up. I'll get rid of the paint, the color. And again, we see that the spacing is kind of all over the place, so we'll double click in the space. Now it's spaced them out, but maybe we want them all the same space. So we're going to highlight that this way, and now they're all effectively the same space. Let's make it a little bigger for the acceleration. Now we'll hit center. They're all aligned centered. That's good. Let's take a look. This looks a lot better. This is a nice, we're getting there with our presentation. Now remember, even though in science the thing is the data and the results, the science, there's always something to be said for a little bit of quality in presentation. So we want to try and make these look nice and fit well on the page. So now you have this. Let's go ahead and highlight the top. We'll make that bold. And seems like we're doing pretty good here. We can even highlight the entire section, come up here and put a grid over top of it. That looks pretty nice. But you may notice that there are something doesn't look quite right with this. And the answer is that if you notice, once again, decimal place has been removed from some of these, even though they were measured with the same system and should have the same number of sig figs. Excel took that out because Excel was actually designed for industry and not for science. So we work with what we can. So let's highlight this time. We have 1 decimal place of sig fig. We'll use our formatting 1, 2, and now we've got 1 sig fig for all data points. Your position, velocity, and acceleration are all 2 sig figs, so just highlight that whole section like so. Close it down, add and subtract your zeros, and then come out of the way. And now this table is ready to be transported, copied and pasted into your lab report or other material. That does it for this part of the tutorial. Don't forget to check out the tutorial that covers making charts and graphs and making those ready for presentation. See you around the lab. Tables and so forth is the biggest thing that you'll be doing, and that's a bunch of blah blah blah. We'll try again. Mess that up. Okay, so most of the time the data you're going to okay, so that okay, so most of the data you're going to deal with is going to be I'm sure I know how the end of sentences go.